Welcome to Clearly Conveying. I am Jeff Poe and this is Mr. Chris Long. Today we'd like to speak to you about how to get the maximum life from your pillow block bearings that are mounted on a conveyor pulley. So Chris, obviously there's a lot that goes into the life of a bearing, and one of the most important things is ensuring that that bearing is properly mounted to the pulley shaft, which we won't go into detail today. But assuming that that pillow block bearing is properly mounted to the conveyor pulley shaft, what's the next most important thing?
Once we get it mounted on the shaft correctly, we want to look at how our customers are going to be mounting it in their application. You know, we want to start and make sure we've got a great foundation to begin with before we ever start rotating this bearing and start putting it through its paces.
Okay, now that's an important subject that you just mentioned, making sure that you have a good foundation to mount the bearings on. So Chris, in your experience, how often do you encounter bearing pedestals on a conveyor that are perfectly level?
You rarely ever see that.
Rarely.
And people oftentimes aren't even checking and looking for that anymore, you know.
Right.
The days of having the millwrights out there putting these bearings into application are disappearing. So more and more we're seeing maintenance people doing this as part of their everyday job, along with every other thing that they're responsible for doing out there. So a lot of people aren't taking a lot of care with that and paying attention to it, so maybe we'd like to just bring that back up to the surface and bring a little bit of attention to it.
For sure, because one of the things that we do know is when a pillow block bearing is properly mounted to the shaft, and when the pulley assembly is properly mounted to the conveyor structure, that sets you up to get the maximum life out of your conveyor pillow block, or out of your pulley pillow block bearings. Essentially, at that point, it's just a matter of making sure it gets the proper amount of grease, right?
Absolutely.
So let's dive into that a little bit. Assuming that we have this pulley assembly and it's ready to mount onto the conveyor structure, one of the first things that we want to look at, as you mentioned, is how level is that bearing pedestal? And when you're looking at that, there's actually three different planes that you have to look at. One obviously is the pillow block bearing. Is it tilted, or it could be skewed, or it could be unlevel from the front of the foot pad to the back of the foot pad. So we have to address all of those. What can you use rather to help ensure that your housing is level on that pedestal?
Well, the first thing you might want to use is a little bit of care and observe. A lot of times these foot pads have been modified in the past. Sometimes you're going to see some welding slag, or you're going to have a lot of grit or things like that. Make sure you've got a nice clean surface to begin with. Sometimes that may mean a little bit of prep, a little bit of grinding work or something like that to make sure you have a really nice flat surface. Once you've achieved the flat surface though, as you mentioned, we're going to want to level that. So there are pieces of shim stock out there available for leveling those bearings and getting a nice level foot pad.
And so you can cut that shim stock to the size of your foot pad and use what you need. I've seen a lot of millwrights, for example, when they're installing a conveyor pulley assembly to the conveyor structure, they'll actually use a machinist level, and they'll lay it on top of the pulley, assuming that you're taking into account any crown in the pulley, and they'll ensure that the pulley assembly is level from one pedestal to the next. And so that would be one of the first steps, right? And if you have one side that's lower than the other, you can use shim stock to get it up to make sure it's level.
Right.
Now, if you had a pulley pillow block that was level, but the housing was tilted left to right on just one pedestal, how do you remedy that?
Well, you can shim one side of the bearing pedestal.
So you could use like a full length shim, cut it in half, and just shim one side of the bearing foot pad for the full length to take care of the tilt to make sure it's level.
Absolutely,
right?
yes.
And then of course, when your pillow block housing may be skewed left to right, what's a good way to identify that misalignment, and how would you correct that?
Well, one way to look at that is we will sometimes look at the LER sealer and make sure we've got a nice even gap all the way around that.
Yeah.
So it's not pinched off or completely tight on one side of our bearing. That's an indication that we do have a lot of misalignment that we need to take care of.
And that's probably one of the easiest visuals that you could use when you're determining the alignment of your housing onto your conveyor structure, is measuring that gap around your LER seal. And if you have equal gap all the way around the seal, that's telling you you essentially have fairly good alignment. Because keep in mind that with pillow block bearings using LER seals, that LER seal is supposed to turn with the shaft, right?
Right.
And so if your shaft is spinning underneath the seal, that is an indication that you have some misalignment that needs corrected. And so, Chris, once you get the pillow block housing mounted properly and it's bolted properly to the conveyor structure and it's aligned, one of the things that we like to recommend is they test the pulley. And so generally you're doing this and the belt is pulled back away from the pulley so that you can spin the pulley. So if you try to spin the pulley and it doesn't spin very easily or it's really hard to spin, what's that telling you?
That's telling you got some binding going on somewhere
Right.
that needs attention.
Right, binding. And if you don't address that, keep in mind that pulley shafts are made from steel, but the LER seals, what material is that
They're
made
going to
from?
be aluminum material.
They're made from aluminum. So if you run this pulley and the bearing pillow block housing is bound up in some way, what's that going to do to your aluminum seal?
It's going to eat those seals up really quickly.
And one of the easiest ways to identify if you have binding going on after you start running is you can take the temperature of these bearings, right? And so if you have a bearing that is just 10 degrees above ambient, that's fairly normal, right?
Absolutely.
But if you have a bearing what's considered running hot, what would you consider running hot? Like 80, 90 degrees above ambient, something
Yes,
like that?
absolutely.
Yeah. And so if you have a bearing that's running hot, that is another indication that you have some misalignment in your bearing housing. Your bearing may be fine. And a lot of times customers or maintenance personnel, they may think, oh, I've got a bad bearing, and it has nothing to do with the bearing, it's the housing alignment, right?
Absolutely. They think that the bearing itself is heating up, and that's the initial source of their problem. Oftentimes, it's the seals that are bound up. The seals are generating heat from the friction as they're rotating, and it makes the entire assembly heat up.
Heat up. And that can bake the grease out of your bearing, and if you don't address that in a fairly quick way, it could lead to premature bearing failure.
Yes, absolutely will.
We talked a lot about the alignment. Let me touch on another important subject. So each pulley assembly that's using pillow block bearings has typically a free and a held bearing.
Correct.
So you have a held bearing that's mounted on one side and a free bearing that's mounted on the other. And that free bearing, can you define that for us? What's that mean when we say this is the free side bearing? What does that mean?
Well, we like to keep held in a free because as we heat up and this shaft gets hotter, there's thermal expansion that's going on there, and it's going to shaft's going to grow.
So that shaft's going to grow in length. So if that shaft leaves the factory in the winter time and it's, say, 78 inches long, and then you install it, and then in the summertime it's 100 degrees out, it could grow 1/8 of an inch. It could typically grow longer. And so you have to allow for that shaft growth, you have to allow for that expansion, right?
Yes, that's where the free side comes in. So we have internally on these bearings, there's one side where the rotating assembly, the actual roller bearing, is capable of sliding back and forth inside that housing to take up some of that growth.
Let's take a look at that. Let's take a closer look at that. Looking inside of our bearing, we have this set up to actually demonstrate and show that the bearing is centered, this free side bearing is centered in the housing, and this will allow this shaft to grow 3/16 of an inch in either direction. As long as when you mount the conveyor pulley assembly to the structure, you ensure that that bearing is centered in the housing before you bolt it down.
Absolutely.
So, Chris, that brings us to when you have this pillow block bolted up on your shaft, ready to mount onto the conveyor structure, how do you ensure that that free bearing is centered in the housing?
Right, because you're usually out there doing the install, and that's a terrible environment to open up a bearing in.
And you don't want to do that.
Avoid that as much as possible.
Yeah,
right?
You don't want to remove the cap out there in the environment. That's
Yes.
right.
Yeah, so there are a few tricks, and I think you've used several of them, in your travels over the years, and it's oftentimes centered around this grease zerk right here.
That's right. So one of the best ways is to remove the grease zerk. Most of the time your grease zerk in your pillow block housings is located in the center of the housing, and so you can remove that grease zerk. You can take a Q-tip and clean out any grease that might be in the port, and look inside to see if you can see the W33 grease groove that is on the outer race of the bearing. So again, when these bearings are installed, you can see it has a grease groove that goes right around the center of the outer race of the bearing. And when you have this pillow block installed in your conveyor pulley and you're mounting it to your conveyor structure, if you remove that grease groove, clean the grease out of the port, and look for that W33 groove, that will ensure that your free bearing is actually centered in your housing before you bolt it down.
Yep, it's got room to both grow and shrink from that point.
So Chris, maybe let's just change gears there and wrap it up with a few thoughts about bearing maintenance and how often should you grease?
That's a question we get all the time, and that's a very difficult one to assess and tell one person, well, you can use this everywhere, because it's going to vary with the application. Some applications are really warm. Temperature's going to change how often we're going to be greasing, how contaminated, how dirty the environment is another, and how many shifts a day, if they're running around the clock or if they're running an 8-hour shift. So those are all important things to consider when you're talking about frequency of greasing.
And that brings up a good point. So from what I'm understanding with your comment is that you should grease based on the level of contamination. And so if you have heavy contamination, you grease more often. Mm-hmm. So there's a lot of misconceptions out there when it comes to greasing bearings. Can you share a few thoughts about the differences between a high-speed bearing and a low-speed bearing, like when it comes to too much grease?
Yeah. One of the things we hear all the time is, well, you don't want to over grease as well. And that is important in a lot of applications. The faster that bearing spins, the less grease you can actually put in there before you start overheating the bearing.
So however, as an example, I'm sorry, but as an example, that would be like a motor bearing or a fan bearing. I mean, those bearings are turning like 1,200, 1,500, 1,800 RPM.
Absolutely.
Yeah, how fast is a conveyor pulley bearing
You're
turning?
talking about something that's turning 100 RPM or 200 RPM.
Or less.
Or less,
right,
depending.
Right.
Yeah, depending on the speed of your conveyors. But we're talking about very low speed bearings here. So we can actually fill these up. And as you know, when we send our SAFs out of our factory, they come with 100% grease fill. We fill the entire cavity of those with 100% grease when we send them out. And that's probably a source for a lot of the calls that you may have gotten over the years, because what happens first thing when they fire that bearing up?
Yeah, that grease purges as it warms up during the initial startup.
Right, so. Exactly. But we don't have to worry so much about over greasing our bearings. We've got purgeable seals. LER seals will purge out any excess grease you might put in there.
So essentially you can't over grease it, can you?
Not at these low RPMs,
yeah.
No.
Yeah, you can't. And the more grease that you put into it, the better, because it just accentuates the purge and helps to flush the contamination out of the bearing, correct?
Absolutely. We're not doing it as much to replenish the lubrication in the bearing as much as we are usually to purge those contaminants and keep them from getting into that bearing.
Excellent, excellent. So just to recap, in order to get the maximum life from your conveyor pulley bearings, number one, we need to ensure that they're mounted properly to the pulley shaft. And number two, we need to ensure that the pulley assembly with the pillow block bearings is mounted properly to the conveyor structure, paying particular attention to the housing alignment and the location of that free bearing housing. And then number three, greasing based on the level of contamination that you have.
I think that sums it up.
Awesome. Well, thanks everyone for joining us today. We'll see you next time. Now we're going to move this side of the conveyor pulley 1/2 inch so that you can see how much the load increases with just a very small change in axial location on the take-up frame.